Hello guys, I am back with the 5 QA and again we are solving the next 16 to 20 questions from the physics question paper of 2017, that is October session paper 11. Well, let's move to our questions. Question 16 asks us, in which substance is the conduction of thermal energy mainly due to the movement of electrons? Okay, for solving this problem, let's go to this option one by one. First of all, the air. Uh, Conduction occurs by movement of air molecules in the air, so this can be omitted. In ice, the ice molecules vibrate and they come in touch with each other. By this method, the energy is actually transferred. And the 3 is yeah. Option C is iron. Iron conduction occurs by the movement of electrons, and the last part is water. Water actually conduction occurs by movement of water molecules. So here the answer will be C, iron. Let's move to question number 17. Here we are asked, four similar metal plates are the same distance from a heater that emits infrared radiation. The plates are painted bold black, dull white, shiny black and shiny white. Which plate absorbs the most radiation? Which plate reflects the most radiation? We need to understand how the actual is different surface acts to radiation. Now actually what happens, the dull blacks, they are good absorbers and good emitters of radiation. And for this example, the cooling fins on the back of a refrigerator are painted black. Now light or shiny surfaces are poor absorbers or poor emitters of radiation. That's why actually this many surfaces are painted light or shiny for reflecting the lights or the heat radiation. That's why on a hot day we normally wear bright white dress to reflect the light and reduce absorption of heat energy. So taking these two concepts, we can clearly see that dull black absorbs most radiation and shiny white reflects most radiation. So our answer will be 17B. Now we look at question 18. This is a simple question, a straightforward question actually it is. A wave is traveling in water in a glass-sided train. The diagram shows a side view of the wave at one instant. What are the amplitude and the wavelength of the wave? Okay, from the diagram we can see that this is the amplitude and the wavelength is here. So from this we can see that amplitude is 4 centimeter and wavelength is 10. So the answer will be B. It's 18B. 19 asks us, an earthquake travels through the solid surface of the earth from east to west. The solid surface vibrates in a north-south direction. How can the earthquake be described? For this answer, we need to have a clear understanding of waves. Actually, there are two forms of waves. They are longitudinal wave and transverse wave. Now, what is longitudinal wave? Longitudinal wave is a wave which transforms, in which the particles of the medium wave travel in a direction parallel to the direction of the wave. On the other hand, a transverse wave is a wave in which the particles of the medium wave travels in a direction perpendicular to the direction of the wave, and the examples can be radio, light. On the other hand, examples of longitudinal wave can be sound wave. From these two descriptions or definitions, we can clearly see that the answer will be D, because in which uh, the the wave is traveling east and west, but the vibration is traveling north and south, so they are perpendicular to each other, and this is a definition of transfer wave, so the answer will be 19D. Now the last question is 20. This concept is based on refraction and reflection. A solid plastic cylinder is immersed in a liquid of reflective index 1.4. Light traveling in the plastic cylinder strikes the inside surface at an angle of incidence of 70 degree, and the light undergoes total internal reflection. What are the values of the critical angle in the plastic and the refractive index of this plastic? Okay, there are two terms that we need to know, that is refractive index, total internal reflection, and critical angle. Now, what is total internal reflection? This is like we first need to know what is critical angle. Actually, when a light travels from a dense medium to a less dense medium, the light refracts away from the normal. So here if it goes like this, the light will travel like this. Now if I increase the angle of incidence, there will be time when the angle of refraction is 90 degree. This is called the critical angle. More precisely, the critical angle is the angle of incidence for which angle of refraction is 90 degrees. When light is traveling from a dense medium to a less dense medium. And if we increase the internal critical angle, that the angle of incidence greater than the critical angle, then we will have total internal reflection, that is the light is reflected back to the same medium. So in this question, the critical angle will be less than 70 degrees because it is getting reflected, so certainly the critical angle will be lower than this. And the light is traveling from a dense medium to a less dense medium. The plastic is dense medium and the liquid is less dense medium, so the refractive index of plastic will be greater than the refractive index of liquid, so it will be greater than 1.4, less than 70 degree and greater than 1.4. So our correct answer is C. That's all guys. I hope this will be helpful for you, and happy learning.